Dear friends, welcome to EaziLessons. In this video, we will be discussing about how to insert a particular node in the beginning and end of a doubly linked list. We already told that doubly linked list is otherwise known as a two-way list. That means we can traverse the list both in the forward direction and the backward direction. And in here, insert a particular item in the beginning of a doubly linked list. Okay, so consider a doubly linked list having 4 nodes, and here I have stored 10, 20, 30 and 44 elements. Each node has 2 pointers, as we have already told, a previous pointer and next pointer, and a previous pointer always points to the previous node and next pointer always points to the next node. And what about the previous pointer of the first node? It is always set as null as it contains no previous nodes. And in the same way, the last node's next pointer will always be set as a null value because there is no next node to the last node. So, when the user wants to insert an item in the beginning, say 5, in the beginning of the doubly linked list containing 4 nodes, what we have to do is that here the algorithm has been shown in the screen. You can watch it. The first step is set a temp equal to head, that is starting address is being copied onto the temp. And then after that we are creating a new node n. So by malloc function we are creating a new node like this, and let the address of the new node be 7000. Okay, and in the next step we have told that set n.num equal to item, that is we are inserting that particular item in the new node, and set n.previous equal to null. After insertion, this node is going to be the first node of the linked list, so the previous node should be null. So here n.previous is set to be null, and after that we have to insert this new node before the first node of the linked list, the existing first node of the linked list. For that, we are saying that set n.next equal to temp. What is temp? Temp contains the address of the previous first node. So we are saying that the next pointer of the newly created node should be pointing to the first node, that is 1000. So here the next pointer is set as 1000, that is this will be pointing to the old first node. And what about the previous pointer of the first node? It was null. So by changing the null value, we are setting the address of the newly created node in the previous pointer of the temp, that is the previous pointer of the node which is located at the 1000 address. So here the previous pointer is set as 7000. So a link is being established between the new node and the old first node. And then what we are doing is that we are changing the starting address. Actually, the starting address head contains the address of temp, that is 1000, and that is being changed to the address of new node, that is head is set as 7000. So in this way, a new node is being inserted in between or before the first node of the doubly linked list. And we will be discussing the program for that. Before that, let us look the insertion of an element at the end of a doubly linked list also. For inserting at the end, first of all we have to move to the last node. So the first task we have to do is to move to the last node. So after storing the starting address in temp, we are going to move to the last node. For that, we have implemented an while loop. Repeat while temp.next not equal to null, temp equal to temp.next. So this loop will be repeatedly executed until a null value is found at the next pointer of the temp. So that happens at the last node. So when the last node reaches, the loop exits and we get the address of the last node. So by finding the address of last node, we are going to insert a new node to the next of this last node. So let us look how it happens. So here what we have done is that after reaching the last node, we are creating a new node n. So a new node is being created in the address 5000, and in the new node we are placing the item to be inserted. So we are saying that set n dot num equal to item. So 50 is placed in the information part of the node. Then set n dot next equal to null, because we know that this node is going to be the last node, and the next pointer of the last node will always be null. So in this case, so we are setting as null in the n dot next. And after that, we have to change the connection between temp and n. So temp now contains the address of the last node of the doubly linked list, and so the next pointer of the temp is set as null. So by changing the null value, we are going to place the address of newly created node in the place of null value. So 5000 is replaced here, means a null value is replaced here with 5000. So here next pointer points to the newly created node. And what about the newly created node's previous pointer? That has been set to the temp. So a new node is inserted at the end of the doubly linked list by adjusting only 2 or 3 simple pointer adjustments. Let us look onto the program. Hope you understand the insertion. If you have any doubts, try to watch once again, and then if the doubt exists, please type it in the comment box. You can ask any doubts. You can suggest any changes in the presentation. Okay, so let us move on to the program. Okay, this is a program for inserting a node in the beginning of the doubly linked list. Okay, so let us look. First of all, a structure has been defined. Struct dlist int num information part is given. 2 pointers are given as next and previous, and we are changing the name of the structure as node using type def, and then we have declared 3 functions, and out of that create an f display. You know that we can display the doubly linked list in 2 ways, in the forward order and backward order, but in here I have shown only forward display. So create f display. These 2 functions are declared as void functions, but they are taking one single argument, that is a node pointer or a structure pointer. And third function is ins beginning, which takes 2 arguments, a structure pointer and an integer item, that is item to be inserted. And we are having a return value node star. And in the main function, what we have done is that we have created a new node, and then the address of the new node is set as a starting address, and the previous pointer is set as null. The first node, we know that the previous pointer of the first node will be set as null. So here the previous pointer is set as null, and then using create function we are going to create a doubly linked list. So the program control will be shifted to the create function by taking the starting address, and while reaching the create function, the user is being asked to enter the number to be stored in the newly created node. Enter the number, scanf %d ampersand t.num. So after entering the number, the system asks the user whether he wants to continue or not. He wants to store any more nodes or not. And if the choice is 0, t.next is set as null. Otherwise, if the user wants to continue, we are creating a new node using malloc function, and the address is stored in the next part of the node. And at the same time, as we are dealing with a doubly linked list, we have to set the previous pointer also of the newly created node. So we are saying that t.next.previous. That means t.next means what? It contains the newly created address of the node. Newly created address of the node. Okay. And we are saying that t.next.previous equal to t, means the previous pointer of the newly created node is set as t. T means the currently accessing node into which we have already placed the element, that is the previous node. So the address of the previous node is placed in the previous pointer of the new node, and then we are calling the create function as a recursive function by passing the address of the newly created node. And again the program control will reach here in the create function, and the process will continue until the user enters the choice as 0. And after that the program control reaches back to the main function, and after that we are displaying the doubly linked list using f display. So f display function is being called, and the program control will be taken on to the f display function. Here the while loop is being executed until the address of the t, that means t contains a starting address. T is used as a formal argument here, so t contains the address of the first node. So until t becomes null, a while loop is being implemented, and each time the while loop is executed, the information part is printed and the address is being moved on to the next node. So after f display, again program control returns back to the main function, and then the system asks the user for the item to be inserted. And after reading the item, we are calling in's beginning function by passing the starting address and item, and also having a return value. So the program control will be shifted to in's beginning function, and there we are creating a new node n, and we are placing the item in the information part, and we are setting the previous pointer as null, new dot previous equal to null. So after that the starting address is being copied onto the temp, and the next pointer of the newly created node is set to temp, n dot next equal to temp, and temp dot previous equal to n, and then we have to say that the starting address, the address of the new node is set as a new starting address, and this new starting address is being returned to the calling function, that is main function. And after returning to the main function, we are again calling display function for seeing what is the current situation of the doubly linked list. So after insertion, what is our doubly linked list? For that, knowing that we are calling the f display function again, and all the nodes will be displayed including the newly added node. So that is about insertion at the beginning of a doubly linked list. Let us execute the program. So here I am giving a number 10. So 3 nodes are given as 10, 20, 30. And then the system is asking for newly inserting items, so I am giving 6. So after insertion, the linked list is like this, that is 6 is being inserted in the beginning of the doubly linked list. So that is all about the insertion at the beginning, and then let us move on to the insertion at the end of a doubly linked list. Here similarly as in the previous program, structure has been defined, functions has been defined. Here instead of in's beginning I have used in's end. There is no other changes, and in the main function we are creating a doubly linked list using create function. So, and before inserting we are displaying the doubly linked list, and after that user is being asked for the item to be inserted. So an item is given, and after that in's end function is called by passing the starting address and item. So here the only difference is in the function in's end, that is a create function is similar, same as in the previous program, and also f display is the same as in the previous program. So the difference is here in the in's end function, that is the user want to insert the node at the end of doubly linked list. For that we are creating a new node using a malloc function, and we are placing the information part in n.num, and we know that after inserting this node is going to be the last node, so the next pointer will be set as null, and then we have to find the address of last node. For that the starting address is being stored in the temp, and using the loop while temp dot next not equal to null, we can find easily the address of last node. So after getting the last node, the next pointer of the last node was actually set as null. So that null value is being changed with the address of the newly created node, temp dot next equal to n. And what about the previous pointer of the newly created node? That is being pointed to the temp. That is end dot previous equal to temp. So that is all about insertion. At the end, let us execute the program. Here I am giving three nodes, and an item is given as 40 to insert at the end of the doubly linked list. So 40 is being inserted after insertion. Okay, so that is all about the program. Hope you understood the video. Kindly share among your friends. Please like, subscribe, and put your bell icon on so that you will get the notifications soon. So once again, thank you. In the next video, we'll be discussing about the deletion of nodes in doubly linked list. So till then,